activity, we're going to be looking at a series of topics, all related to right angles. So first, we're going to say what is a right angle, then what are the sides of the triangle called, which are the six trigonometric ratios, and which is a Pythagorean theorem, and the special angles. We'll also be analyzing three different word problems. All of these, our names are Palmira Lozano, Catherine Villafuerte, Fabiola Salcero, Paulina Guantarrubio, and Patricia Martinez. So, now Catherine will explain right triangles.
Right triangles and its sides. A right triangle is any triangle that contains a 90-degree angle or a right angle within itself, hence the name right triangle. Now the legs. The longest leg, which is opposite from the right angle, is called the hypotenuse. And the other two sides that create the right angle are called the legs.
Trigonometric ratios. For any right triangle, there are 6 trigonometric ratios. Sine equals opposite on top of hypotenuse, cos equals adjacent on top of hypotenuse, tangent equals opposite on top of adjacent, and then there are the opposites, which are cosecant, which is hypotenuse on top of opposite, secant, hypotenuse on top of adjacent, and cotangent, which is adjacent on top of opposite. You can use SOHCAHTOA to remember. Pythagorean theorem. The Pythagorean theorem states that C2 equals A2 plus B2, C being the hypotenuse and A and B being the other sides. What's it for? In a right angle, when you have 2 out of 3 angles, you can determine the third one by using the Pythagorean theorem.
Special angles. The special angles inside a right triangle are 30, 45, and 60. 30 and 60 being complementing angles, meaning that 30 plus 60 equals 90, and 45 being its own complementary angle, meaning that 45 plus 45 equals 90. Now, what this creates is 2 types of triangles, the 45, 45, 90, and the 30, 60, 90. Now, they both add up to 180 degrees, which is what every triangle should measure. Now, they are called special angles because they do not need much calculation for you to get the sides.
Problem number 1. Problem number 1 states that a specific point in the floor is 145 meters from the bottom of the tower. The angle of elevation from that point to the top of the tower is 59 degrees. So now we have to determine the height of the tower. In order to find the height of the tower, we'll be using the law of sines. The law of sines states that sine A over A is equal to sine B over B, that is equal to sine C over C. Okay, now we have to find sine A over A. To find sine A, we have to add both degrees that we already have and subtract them by 180. The degrees that we already have are 90 and 59, so our result will be 31 degrees. We place sine of 31 over 145 because 145 is the side that is opposite the 31 degrees. Now, we put sine 31 over 145 is equal to sine of 59 over x. We place sine of 59 because it's the degrees that are opposite the side we're looking for. By using cross multiply, we can see that the height of the tower is 136.49 meters.
So, if a 13-meter tall tree casts a shadow of 22 meters, what is the angle of elevation? So in this case, we will use tan since it is the opposite over adjacent from the angle. In this case, the opposite would be 13 and the adjacent would be 22. So it would be tan angle equals 13 of 22, which then we only pass the tan to the other side and leaving the angle out. So it's arctan of 13 over 22, which will be 30.58 degrees.
For a final problem, a tank wants to hit an enemy plane. The tank is 500 meters away from a certain point and the plane is 100 meters above a certain point. Determine the angle of elevation at which the tank must shoot. To solve this problem, we must first find the hypotenuse of the triangle, the right triangle. So it would be a squared plus b squared equals c squared, and the hypotenuse would be 509.90. Now that we have this information, we can use the law of sines to get the answer to the problem. So it would be x over 100 equals sine 90 over 509.90. Using cross multiplication, we can find out that x is equal to 0.196. Now we have to use arcsine tool to find the solution, and in this case, our angle of elevation should be 11.303. With this information, our tank can now hit the enemy plane and be victorious.